In today's video, we embark on the ultimate truck education. So, if you ever wondered why some truck tires don't touch the ground, or why some trucks have such long wheelbases, or just any of these questions, then sit back and enjoy an educational roller coaster. Now, let's get started. Today, we're diving into a subject that is crucial for anyone who's ever shared the road with a massive truck: air brakes. These systems are not only essential for truck drivers, but also for ensuring the safety of everyone on the road. So why do big trucks use air brakes instead of the hydraulic brakes you'd find in a regular car? What makes air brakes superior, and how do they work? In this video, we'll take a deep dive into the intricate mechanics of air brakes and explore why they are the preferred braking system for heavy-duty vehicles. Imagine driving down the highway in a car that weighs about 4,000 pounds. Now, think of the massive trucks you see that weigh anywhere from 10 to 20 times that much, or even more. A fully loaded semi-truck can easily tip the scales at 80,000 pounds or more, depending on its cargo and the country's regulations. Stopping that much weight safely requires a braking system far more powerful and reliable than what you find in passenger cars. Passenger vehicles generally use hydraulic brakes, a system that relies on brake fluid to transmit force from the brake pedal to the wheels. While this works efficiently for smaller vehicles, it falls short for larger trucks due to severe key limitations. Hydraulic brakes, for instance, are prone to failure if a leak occurs. Any break in the hydraulic system could cause the vehicle to lose braking power completely. Now, imagine that happening to a truck weighing 40 tons. It's a recipe for disaster. So, this is why air brakes are the system of choice for large trucks. The core advantage of air brakes is their fail-safe design. Even if there's a problem in the system, the brakes will automatically engage to stop the truck. Unlike hydraulic brakes, which rely on a closed fluid system, air brakes use compressed air, making them more robust and dependable in extreme conditions. Another reason for air brakes is scalability. As trucks grow larger and heavier, air brakes can be adapted to provide more braking power without needing an overhaul of the entire system. This flexibility makes air brakes ideal for everything from medium-duty trucks to the heaviest vehicles on the road. Now that we understand why air brakes are necessary, let's break down how they actually work. The air brake system in a big truck is an intricate web of components, each designed to ensure safe, reliable braking under even the most demanding conditions. The system begins with the air compressor, powered by the truck's engine. The compressor's job is to take in air from the atmosphere, compress it, and send it into storage tanks. These tanks act as reservoirs, holding enough compressed air to allow the brakes to function multiple times, even if the compressor temporarily stops working. This redundancy is crucial because it means that the truck won't lose braking power if the compressor fails. When the driver presses the brake pedal, air from the storage tanks is released into the brake lines, which carry it to the brake chambers located at each wheel. Inside each brake chamber is a diaphragm or piston that moves when the air pressure is applied. This movement pushes a rod connected to the brake mechanism, forcing the brake shoes against the brake drums or discs, which in turn creates the friction needed to slow down the truck. One unique aspect of air brakes is their use of spring brakes. In many trucks, these brakes are held in the released position by air pressure. If the air pressure drops below a certain level, the springs automatically engage the brakes, stopping the truck. This is the core of the system's fail-safe design. If something goes wrong, the brakes are applied, not lost. Another key feature of air brakes is the dual-circuit system. Most trucks are equipped with two separate air circuits that control different sets of brakes. This design ensures that if one circuit fails, the other can still function, allowing the driver to maintain some braking control. This extra layer of safety is essential for trucks that frequently travel long distances and carry heavy loads. especially when traversing mountainous terrain or extreme weather conditions. One of the less obvious but critically important components of the air brake system is the air dryer. When the air compressor draws in air from the environment, it also pulls in moisture. If this moisture isn't dealt with, it can condense inside the brake lines and storage tanks. In cold weather, this moisture can freeze, causing blockages in the lines. In any weather, water in the system can lead to corrosion and mechanical failure. The air dryer's job is to remove moisture from the air before it enters the system, ensuring that the compressed air remains dry and clean. This is essential for keeping the brake system reliable, no matter the weather conditions. Air brake systems are also equipped with several safety valves. For example, the governor controls the compressor's output based on the system's air pressure. When the pressure reaches a certain level, the governor signals the compressor to stop, preventing the system from becoming overpressurized. There are also pressure relief valves designed to release air if the system's pressure exceeds safe levels. These features are in place to protect the entire braking system from damage due to excessive pressure, ensuring that it operates safely and efficiently. Have you ever driven by a truck and seen one or even two of the truck's axles floating above the road and wondered why it's hanging up there? And why not all the wheels touch the ground? Then don't worry. In this video, we'll explain to you why some trucks' tires don't always touch the ground, but also teach you a little about how truck axles work, the types of truck axles, and how they affect the trucks. Let's start with explanation of the axles. An axle is a rod or shaft that connects two wheels and supports the weight of the vehicle. Axles are essential components of any vehicle, including trucks. Axles are connected to the wheels by bearings. When the engine turns the transmission turns the drive shaft, which turns the differential, which turns the axles. The axles then turn the wheels, propelling the vehicle forward. There are two main types of truck axles. Steering axles are located at the front of the truck and allow the driver to steer the vehicle, or in the back to create shorter turning radius. Drive axles are located at the rear of the truck and provide power to the wheels, or in the front in case of an all-wheel drive. In addition to steering axles and drive axles, there are also two other types of axles that can be found on some trucks. Tag axles are located at the very rear of the truck and provide additional support for heavy loads, and also called boogie axles in some places. And then there are lift axles, which are often located between the drive axles and can be raised or lowered to improve fuel efficiency or traction. And it's exactly this axle you have seen, floating as it can be lifted from the ground. But what's the point of driving with an axle that's not on the ground? Well, actually, there are multiple reasons for it, but let's start with better grip and traction. Lift axles can be lowered when the truck is fully loaded, distributing the weight more evenly among the axles. This increased weight on the tires enhances traction and grip, especially in adverse weather conditions like rain, snow, or ice. As an example, Volvo have a tandem axle lift function to really improve grip when needed. Ground pressure. When a truck is fully loaded, it can exert significant pressure on the road surface, potentially causing damage or sinking into softer terrain. By lowering the axle and distributing the weight over several axles, the overall weight is distributed more evenly, reducing the ground pressure and minimizing road wear and tear. Load adjustments. Lift axles allow truck drivers to adjust the weight distribution of the cargo. This is particularly important for complying with weight regulations, as different jurisdictions have specific limits on axle weights. By raising or lowering the lift axles, the driver can ensure that the load is evenly distributed within legal limits. Fuel efficiency. Running additional axles on a truck consumes more fuel due to increased rolling resistance. By lifting the axles when not needed, such as when the truck is empty or carrying a light load, you can improve fuel efficiency. This reduces operating costs and minimizes environmental impact. Legal regulations. Lift axles play a crucial role in complying with weight regulations imposed by local authorities. Overloaded vehicles can incur fines, and lifting or lowering axles allows drivers to adjust their truck's configuration to remain within legal weight limits. Maintenance and costs. Lift axles, like any other component, experience wear and tear over time. However, by raising them when not in use, you reduce the mileage and stress on these axles, extending their lifespan. This leads to lower maintenance costs and less frequent repairs. In addition, the tires also wear less when the axle is lifted, and they do not roll along. Safety. When a truck is fully loaded, the additional axles provide more braking power because they have more tires making contact with the road surface. This means that the truck can stop more effectively and efficiently, reducing the risk of accidents caused by inadequate braking. Lift axles, when lowered, increase the stability of the truck, especially when navigating corners or during sudden maneuvers. The additional tires help distribute the weight evenly and provide better grip, reducing the likelihood of rollovers or loss of control. How liftable axles work. Liftable axles are usually connected to the truck's air suspension system and can be controlled by a switch in the truck cab. When the switch is activated, air is pumped into the airbags, which raises the axle. When the switch is deactivated, the air is released from the airbags, which lowers the axle. The axle is raised when the truck is empty or carrying a light load. This improves fuel efficiency by reducing the amount of friction between the tires and the road. The axle is lowered when the truck is carrying a full load. This improves stability and handling by increasing the weight distribution of the vehicle. Liftable truck axles are commonly used on long-haul trucks, dump trucks, and construction vehicles. Have you ever found yourself wondering why most American semi-truck engines have power outputs of around 500 horsepower? When the smaller European trucks are available with engines with an impressive 770 horsepower? In this video, we'll unravel the multifaceted reasons contributing to this intriguing power imbalance. But first, let's clarify that horsepower isn't the only important metric, as it also needs torque. Horsepower is a unit of power that represents the rate at which work is done or energy is transferred. Torque is a rotational force that causes an object to rotate around an axis. While torque and horsepower are related, they represent different aspects of an engine's performance. Furthermore, the transmission and gearing also play a role in translating engine power to the wheels. But to keep things simple, this video focused only on horsepower. So let's take a look at the different engines that are offered. In Europe, there are different truck brands like MAN, DAF, Scania, Volvo, Renault, Iveco, and Mercedes-Benz. Each brand has its own unique truck engine. Some brands work together and use similar parts in their engines, making the engine world more connected than we might think. The power of these engines varies from 400 to 770 horsepower, where Volvo and Scania have the two biggest engines, with 750 horsepower, and Scania Big V8 with up to 770 horsepower, making them stand out. The four major engine manufacturers in the US are PACCAR, Detroit, Mack, and Cummins. Also, a lot of Caterpillar truck engines are driving around in the US, but they stopped manufacturing on-highway engines in 2010 due to increasing emissions regulations. The most sold engine in the US is the Detroit DD15, which is a 14.8-liter inline-six engine with 505 horsepower and 1,750 pounds per foot of torque, which is used on the truck brands Freightliner and Western Star. The biggest engines in America is the Cummins X15 with 605 horsepower and the Detroit DD16 with 600 horsepower. Okay, now you have an understanding of the different engines, but we still haven't covered why the American engines are not available with the same big engines as in Europe. So let's get to the first reason why there is such a big difference on the engines. Weight rules, EU versus US. One big reason why we don't see truck engines with more than 600 horsepower in the US is because of the weight rules. The federal limit for the weight of semi-trucks in the US is 80,000 pounds. That's 36 tons, which a 500 horsepower engine is more than capable of pulling through the American roads. On the other hand, in Europe, where there are 27 different countries, each with its own rules, it's a different story. Trucks there often need more powerful engines to handle different kinds of roads and carry heavier loads. Here, the weight limit in most places is 44 tons. However, many Nordic countries have weight limits exceeding 80, 90, and some even over 100 tons. Here, the 500 horsepower engine simply isn't enough, and that's why bigger engines are used. Landscape and infrastructure. The difference in landscapes and infrastructures also helps explain why there's a gap in horsepower between the US and Europe. The US has mostly flat terrain, and its roads don't have many steep climbs. Here, the roads are bigger, longer, and straight. In Europe, it's the opposite. The varied landscapes mean trucks have to go through smaller roads with big changes in elevation. To handle these challenges, trucks in Europe need more powerful engines, leading to the use of larger and stronger ones. This combination of higher gross weight and steep inclines has made a demand for stronger and bigger engines in Europe, which simply isn't needed in America. Market demand. The engine market of any place is formed by the demand, and in Europe there is a demand for the big engines. They not only want their trucks to perform well, but also to look and sound amazing. For example, some drivers prefer engines like the Scania V8, not just because they're powerful, but because they have a unique and awesome sound. We actually made a video all about truck engine sounds, so go watch that if you love the sound of a roaring truck engine. In this video, we'll take an in-depth look at the crucial components that make up a semi-truck, highlighting their functions and importance in the overall operation of these massive vehicles. Whether you're a truck enthusiast or simply curious about the inner workings of these machines, you're in for an informative ride. Let's start with the engine. The engine is the heart of any semi-truck. These trucks are often powered by heavy-duty diesel engines designed for maximum torque and efficiency. Very simplified, diesel engines operate on the principle of internal combustion. Air is compressed in the cylinders, and diesel fuel is injected at a precise moment. The heat generated ignites the fuel, creating a controlled explosion that drives the piston downward, turning the crankshaft and generating power. The engine's primary function is to convert fuel into mechanical energy, which is transmitted via the transmission to the wheels to propel the truck forward. Modern engines are equipped with advanced technologies, such as turbocharging and direct fuel injection, to optimize power output and fuel economy. Almost all heavy-duty truck engines are inline-six engines with 450 to 600 horsepower. Although it may not sound like much compared to a sports car, they provide considerably more torque. For example, the Cummins X15 Performance with 565 horsepower delivers 2,050 pounds per foot, where most cars with 550 horsepower delivered around 470 pounds per foot. The reason all truck engines are inline-six engines is because they are the most fuel efficient, can deliver the necessary power, and are cheap in maintenance costs compared to a V8. Trucks have a wide range of gear ratios to handle various situations, such as starting from a standstill, climbing steep inclines, cruising at high speeds, and even braking. Gears allow the engine to operate within its most efficient RPM range for each situation, optimizing power delivery and fuel efficiency. In a manual transmission, also known as a standard or stick-shift transmission, the driver is responsible for manually selecting the gears using a gear shift lever and a clutch pedal. In an automatic transmission or automated manual transmission (AMT), the process of shifting gears is handled automatically by the transmission's hydraulic and electronic systems, and all the driver has to do is press the speeder. The number of gears in a semi-truck transmission can vary depending on the manufacturer, the application, and the engine. However, the most common number of gears for a semi-truck transmission is from 10 to 18 gears. Axles and wheels. Semi-trucks often feature multiple axles to distribute the weight of the load evenly. Axles support the weight of the truck in the cargo, while the wheels provide traction and maneuverability. Trucks can be put together in many different ways and can be configured as a 4x2, 6x2, 6x4, also called tandem, 8x4, and many other configurations. Most semi-trucks in America are 6x4 with tandem traction, where both rear axles pull along due to weight rules. Where a 4x2 or 6x2 with either leading or trailing axle is the most used in Europe. The axles can also have different maximum loads, which can have an influence on the truck's permitted total weight. Also, the tires on the semi-trucks are of great importance, as they need to have the right load capacity, be fuel efficient, have some longevity, and ensure braking performance in varying weather conditions. Cab and sleeper berth. The cab is the driver's workspace and living quarters. It houses the driver's seat, controls, and instrumentation, and some trucks might have more high-tech equipment than you think. New trucks are equipped with safety systems like adaptive cruise control, lane assist, emergency brake, and much more. The cab size of a truck can vary greatly, as some might not have the need to sleep in the truck where others might be on the road for days or even weeks. Many long-haul truckers are equipped with sleeper berths, providing a sleeping area, storage, and basic amenities for drivers during extended trips. This includes bunk beds, TV, refrigerator, microwaves, cabinetry, and lots of storage space, as well as climate systems to keep the cab warm in cold weather or refrigerate it if it gets too hot. In addition, trucks often have very comfortable air-suspended driver's seats, adjustable steering wheels, and a lot of buttons that can control some of the truck's many functions. Suspension system. The suspension system of a semi-truck plays a crucial role in providing a smooth and controlled ride. Air suspension is commonly used in the rear axle to handle the heavy loads and provide adjustable ride height. The front suspension ensures stability and steering control. The suspension also helps minimize wear and tear on both the truck and the cargo. Some trucks have leaf springs on all axles, some only have air on the rear axle, and some have full air suspension, which is the most comfortable and allows you to adjust the entire height of the vehicle, which can be a great advantage for some types of work. The air pressure can be controlled from a remote control in the cab, so the driver can adjust the desired height. Frame and chassis. Frame and chassis form the structural backbone of the semi-truck. They support the weight of the engine, cabin, cargo, and other components. The frame is designed to handle the stresses of heavy loads and varying road conditions. The frame is made of high-strength steel beams that are welded or bolted together. It's designed to evenly distribute the load's weight across the axles and is carefully specified so that it matches the desired weight load, as well as the size of the cab. If the vehicle must drive with a very high load, some manufacturers can choose a reinforced frame or a double frame, which provides increased strength and load capacity. Braking system. A semi-truck's braking system is a critical component responsible for safely slowing down and stopping the vehicle, which is especially important due to the large size and weight of these trucks. The braking system ensures not only the safety of the truck driver and cargo, but also the safety of other road users. Semi-trucks employ a specialized braking system known as air brakes, which is different from the hydraulic brakes commonly found in smaller vehicles. The air brake system, which relies on compressed air to control and apply the brakes, this system offers several advantages, including increased reliability, improved braking performance for heavy loads, and reduced risk of brake fade during prolonged use. A semi-truck's braking system is pivotal for ensuring safety and control on the road. It influences advanced safety systems like ABS, ESC, collision mitigation, and more. These systems rely on proper brake function to prevent skidding, maintain stability, and respond to potential collisions. Exhaust system. Diesel engines produce exhaust gases that need to be efficiently managed. The exhaust system includes components such as the exhaust manifold, diesel particulate filter (DPF), and selective catalytic reduction (SCR) system to reduce emissions and ensure compliance with environmental regulations. As emissions standards become more stringent, the exhaust system's design and components have evolved to reduce harmful pollutants and minimize the trucking industry's impact on air quality. Over time, the exhaust system of semi-trucks has undergone transformational changes in response to environmental regulations and technological advancements. Have you ever wondered why some trucks have such incredibly long wheelbases? Today, we'll dive into the fascinating world of truck design to uncover the hidden secrets behind those extended frames and why a too long wheelbase might get you in trouble. How it's measured. First, let's clarify what a wheelbase is and how it's measured. A truck's wheelbase refers to the distance between the centers of its front and rear axles. It's a critical measurement in vehicle design, as it affects various aspects of the truck's performance, stability, comfort, and handling. The wheelbase plays a significant role in determining how the weight of the vehicle is distributed and how it behaves on the road. The measurement is usually expressed in inches or centimeters, depending on the region and the measurement system used. Typical wheelbase range. On the American trucks, the wheelbases can vary significantly, from around 140 to over 300 inches, depending on usage, axle configuration, cab size, and so on. However, trucks designed for specific purposes, like hauling oversized loads or intermodal containers, can have much longer wheelbases, sometimes exceeding 300 inches, 762 centimeters. The wheelbase is often chosen based on which trailer the vehicle must drive with, as some rules can be decisive as to whether the vehicle in question can drive with a certain trailer. It is also important that the overhang from trailers cannot hit the rear of the truck cab, or that the rear of the truck hits the bottom of the trail. Historical context. Long wheelbase trucks weren't always as prevalent as they are today. In the mid-20th century, regulations limited truck lengths, hindering the use of extended wheelbases. However, in 1982, a new regulation was imposed that changed everything. The new regulations limited the length of the trailer to 53 feet and no longer included the cab in the length restriction. Now, the truck manufacturers were able to make longer and more comfortable cabs for the long-haul drivers, and slowly, the cab-over was phased out, replaced by the bigger, long-nosed conventional trucks. Before the 1980s, the dominant type of truck cabs was the COE cab-over design, where the engine was placed under the cab. With a short nose, this type of truck had a very good maneuverability. However, very small cabs and poor comfort. As industries expanded and freight demands grew, longer wheelbases were adopted to accommodate larger and heavier loads, and the construction of the U.S. interstate highway system, allowing for faster and more efficient transportation of goods across the country. Longer wheelbases became more practical for trucks operating on these high-speed, long-distance routes, enabling trucks to carry larger loads while maintaining stability at higher speeds. But what are the advantages and disadvantages of a long wheelbase? Long wheelbase trucks offer several advantages. A longer wheelbase tends to offer greater stability, especially at higher speeds. This stability is especially crucial when carrying heavy or oversized loads. Additionally, the elongated design allows for better weight distribution. This even weight distribution reduces stress on individual axles, tires, and suspension components. It also minimizes wear and tear on road surfaces and infrastructure, contributing to road safety and preservation. Longer wheelbases accommodate larger and heavier loads due to improved weight distribution. This is vital for industries requiring bulk transport, like construction and heavy machinery. Longer wheelbases contribute to a smoother and more comfortable ride for drivers and passengers. The extended distance between axles helps absorb road irregularities and vibrations, resulting in reduced jolts and shocks within the cabin. This is particularly important for long-haul trucking, where drivers spend extended periods on the road. In the case of long-haul trucks, longer wheelbases provide space for bigger sleeper cabins. These cabins offer drivers a comfortable space to rest during overnight stops, enhancing their overall well-being and allowing them to adhere to required rest periods while on the road. Disadvantages of long wheelbases. While longer wheelbases on trucks offer several advantages, they also come with certain disadvantages that need to be considered in the design and operation of these vehicles. One of the primary drawbacks of a longer wheelbase is reduced maneuverability. Trucks with longer wheelbases require more space to make turns and navigate tight corners. This limitation can be especially challenging in urban areas, construction sites, and other environments with limited space. Finding suitable parking spots for trucks with longer wheelbases can be challenging, especially in densely populated urban areas. Also, longer wheelbases can make backing up more challenging, particularly when the driver needs to maneuver the truck in reverse. The longer frame can create blind spots, making it harder to see obstacles and pedestrians behind the truck. Trucks with longer wheelbases may struggle in off-road or uneven terrain. The extended frame can cause the truck to bottom out or get stuck when encountering steep inclines, rough roads, or obstacles. The extended length can lead to a higher center of gravity and reduced traction, potentially impacting the truck's ability to climb hills efficiently. Lastly, trucks with very long wheelbases might need a reinforced frame to be able to withstand weight load, which increases the total weight and thus can have a negative effect on the truck's total payload capacity. The perfect wheelbase is... Determining the perfect wheelbase for a truck is not a one-size-fits-all situation. It depends on the specific job or application the truck will be used for, and finding the optimal wheelbase involves striking a balance between the advantages and disadvantages associated with different lengths. Truck manufacturers, operators, and drivers carefully assess the specific requirements of each job to determine the optimal wheelbase that aligns with the intended use and provides the best combination of advantages while minimizing disadvantages. Customized ultra-long trucks. In the world of show trucks and specialty vehicles, customizations know no bounds. Trucks with extremely long wheelbases are often seen at truck shows and exhibitions, showcasing intricate paint jobs, unique body designs, and luxurious interiors. These trucks might be used for promotional purposes, parades, or simply as expressions of creativity and craftsmanship. These trucks are typically built for shows and would not work hauling heavy loads at all. It is for appearance's sake that they are made this way, and you have to say, they're cool. Also, trucks built with ultra cabs are also seen with incredibly long wheelbases, as the huge cabins require a long wheelbase. In America, there's a popular saying, the bigger the better, but this doesn't necessarily apply to trucks. While American trucks are often larger in size compared to European trucks, the permitted total weight they can carry is significantly lower. Additionally, there are notable differences in engine specifications and overall design. But why is that? let's look at the 5 main reasons that American and European truck weight rules are so different. 1. Regulatory differences. Europe. Most European countries are a part of the European Union, EU, which sets harmonized standards for vehicle weights and dimensions to facilitate cross-border trade and transportation within the single market. The EU Directive 96/53/EC sets the maximum weight for a 5-axle truck at 40 tons, approximately 88,000 pounds. Some European countries allow even higher weights under certain conditions. For instance, the maximum weight for trucks can go up to 44 tons, approximately 97,000 pounds, in countries like the UK, France, and the Netherlands for national transport. Certain countries allow higher weights for specific configurations, such as 6-axle combinations that can go up to 50 tons, approximately 110,000 pounds, or even way more in Scandinavian countries like Sweden, Denmark, Norway, and Finland, where 80, 90, and even 120 tons is being tested, approximately 264,000 pounds. Now, how does that compare to America? In the U.S., federal regulations under the Federal Highway Administration, FHWA, set the maximum gross vehicle weight, GVW, for trucks operating on the interstate highway system at 80,000 pounds, approximately 36.3 tons. States can set higher limits for non-interstate roads, but the 80,000-pound limit is widely observed due to the extensive network of interstate highways and the desire to avoid penalties. Also, the maximum weight allowed on a single axle is 20,000 pounds, where a tandem axle has a maximum weight limit of 34,000 pounds. But another reason for the differences are 2. Road infrastructure. European road infrastructure, particularly its highways and major routes, is meticulously designed to accommodate higher weight limits. The roads are constructed with advanced engineering techniques to handle the increased stress and wear caused by heavier vehicles. This robust design includes reinforced pavement layers, durable materials, and comprehensive maintenance practices that ensure long-term performance under heavy traffic conditions. Additionally, European bridges, overpasses, and other critical structures are built with higher weight tolerances. These structures undergo rigorous testing and adhere to stringent safety standards, facilitating the movement of heavier trucks without compromising the safety or integrity of the infrastructure. The design and maintenance protocols for these structures include regular inspections and upgrades to adapt to evolving transportation needs and technologies. In contrast, the U.S. boasts a vast and varied road network, encompassing everything from major interstate highways to rural and secondary roads, while the interstate highway system is designed to be robust and capable of handling significant loads. Many other parts of the network, especially rural and secondary roads, were not originally designed to support extremely heavy vehicles. These roads often have narrower lanes, thinner pavement layers, and less frequent maintenance, which can lead to quicker deterioration when exposed to heavy loads. Moreover, numerous bridges and overpasses across the U.S. may not meet the same stringent standards as their European counterparts. Many of these structures were built decades ago and have not been upgraded to accommodate modern heavy truck weights. Consequently, maintaining lower weight limits is necessary to preserve the integrity of the infrastructure and ensure safety. Regular inspections, load restrictions, and occasional closures for repairs are common practices to manage the wear and tear on these older structures. 3. Economic considerations. In Europe, higher permissible weights for trucks can significantly enhance the efficiency of freight transportation. By allowing trucks to carry larger loads, the number of trips required to move the same volume of goods is reduced, leading to lower transportation costs and decreased emissions. This efficiency gain is crucial in a continent where fuel costs and environmental regulations are stringent. Furthermore, European countries characterized by dense urban areas and relatively shorter distances between major economic hubs derive substantial benefits from maximizing load capacities. Higher weight limits enable logistics companies to streamline operations, improve delivery times, and reduce the overall number of vehicles on the road. The reduction in the number of trips and vehicles on the road also contributes to lower wear and tear on the infrastructure, as fewer trucks are needed to move the same amount of goods. In contrast, the U.S. transportation network is vast and diverse, encompassing long distances, often traversing expansive rural areas. While higher weight limits could theoretically improve freight transportation efficiency by allowing for larger loads and fewer trips, the potential downsides must be carefully considered. The increased weight can lead to more significant wear and tear on roads and bridges, many of which were not designed to support such heavy loads. Upgrading the entire U.S. infrastructure to accommodate heavier trucks would entail substantial costs. This would involve reinforcing pavement, widening roads, and strengthening bridges and overpasses across the country, a monumental and expensive task. Additionally, the extensive rural road network, much of which is less robust than urban and interstate highways, would be particularly vulnerable to damage from heavier vehicles. 4. Logistical requirements. The logistics industry in Europe is highly sophisticated and relies heavily on intermodal transport, which seamlessly integrates road, rail, and waterways. This interconnected system is designed to leverage the strengths of each transport mode, ensuring efficient and flexible freight movement across the continent. Higher weight limits for trucks are integral to this system, as they align with the capacities of both rail and shipping, facilitating smooth and efficient transitions between different modes of transport. This interoperability reduces handling times and costs, making the entire logistics chain more effective. Europe's strong emphasis on sustainability and reducing carbon footprints further incentivizes maximizing load capacities. By allowing trucks to carry heavier loads, the number of trips required decreases, leading to a significant reduction in overall fuel consumption and greenhouse gas emissions. United States. The U.S. logistics landscape is characterized by a strong trucking industry complemented by an extensive rail network for long-distance freight support. The federal weight limit of 80,000 pounds for trucks is a critical element in maintaining compatibility and efficiency across different transportation modes. This limit ensures that truckloads are manageable for both road and rail transport, promoting a cohesive and efficient logistics network. In the U.S., logistical strategies often involve balancing truckloads with rail and maritime capacities to optimize the overall transportation network. The weight limits are reflective of this balance, ensuring that freight can be efficiently transferred between trucks, trains, and ships without exceeding the capacity limits of any mode. This synergy allows for more streamlined operations, reducing the need for frequent load adjustments and rehandling. 5. Environmental and safety considerations. In Europe, the environmental and safety considerations surrounding heavier trucks are meticulously managed to align with the continent's stringent policies and goals. Heavier trucks are often more fuel efficient per unit of cargo, meaning they can move more goods with less fuel, reducing overall emissions per ton-kilometer. Europe's rigorous safety standards and regulations for trucks are designed to mitigate the risks associated with heavier vehicles. These standards include advanced braking systems, stability controls, and stringent driver training requirements. Such measures ensure that heavier trucks can operate safely even under challenging conditions. Additionally, trucks in Europe are typically restricted to a maximum speed of 90 kilometers an hour, with many countries imposing even lower speed limits, often not exceeding 80 kilometers an hour. These speed restrictions are crucial for enhancing safety, as they reduce the risk of accidents and provide more time for drivers to react to road conditions. United States. In the United States, the 80,000-pound weight limit for trucks is a critical factor in balancing efficiency with safety. While heavier trucks could theoretically improve fuel efficiency per trip, they also pose significant safety risks. These risks include increased braking distances, reduced maneuverability, and greater wear on safety-critical components such as brakes and tires. The higher potential for accidents and infrastructure damage makes it essential to maintain a manageable weight limit. In the US, trucks are permitted to drive at much higher speeds than in Europe, with some regions allowing speeds up to 115 kilometers an hour, approximately 70 mph. The combination of high speeds and heavy weights significantly increases the stopping distances required, posing substantial safety risks. Imagine the challenge of stopping a truck weighing over 80,000 pounds while traveling at 115 kilometers an hour. The kinetic energy at such speeds makes it extremely difficult to stop quickly, leading to potentially severe accidents. Therefore, the current weight limit and associated safety regulations are crucial for maintaining a balance between efficiency, safety, and infrastructure preservation. The significant differences in truck weight regulations between America and Europe stem from a variety of complex factors, including regulatory frameworks, road infrastructure, economic considerations, logistical requirements, and environmental and safety concerns. Overall, while both regions aim to optimize their freight transportation systems, the strategies they employ reflect their distinct geographic, economic, and regulatory landscapes. Suspension systems. A truck's suspension is not just a set of springs. It's a complex system that affects ride quality, handling, cargo safety, and overall operational efficiency. Whether you're an owner-operator or managing a fleet, understanding these systems can significantly impact your decision-making. Let's explore the various types of suspension systems, their configurations, advantages, disadvantages, and the best applications for each. Suspension systems are designed to support the weight of the vehicle, absorb road shocks, and maintain contact between the tires and the road surface. They consist of springs, shock absorbers, and other components that work together to provide stability and comfort. The primary types of suspension systems used in semi-trucks include leaf spring suspension, air suspension, torsion bar suspension, hydraulic suspension, walking beam suspension. Each of these systems has unique characteristics that make them suitable for different trucking applications. Let's start with leaf spring suspension, the most traditional and widely used system in heavy-duty trucks. How it works. Leaf springs consist of multiple layers of metal, known as leaves, stacked on top of each other. When weight is applied, the leaves flex to absorb shock and support the vehicle's load. Advantages: durability. Leaf springs are incredibly strong and can withstand heavy loads without deformation. This makes them ideal for trucks that regularly carry significant weight. Simplicity. The design of leaf springs is straightforward, leading to fewer components that could fail. This simplicity often translates into lower maintenance costs. Cost-effective. Leaf spring systems are less expensive to manufacture and install compared to more complex systems. Disadvantages. Ride quality. While leaf springs are great for supporting heavy loads, they can lead to a bumpy ride, especially on uneven surfaces. The lack of cushioning can also transfer road shock to the cab and cargo. Limited adjustability. Leaf springs do not provide the flexibility to adjust for varying load conditions easily, which can affect handling and stability. Many trucks use leaf springs on all axles for maximum strength and reliability. This is particularly beneficial for freight carriers that regularly haul heavy loads or operate in rough terrain. 3. Air suspension. Next, we have air suspension, a system that uses air-filled bags instead of traditional metal springs. How it works. Air suspension systems consist of rubber or polyurethane airbags that inflate or deflate based on the load. A compressor fills the bags with air, providing cushioning and support. Advantages: superior ride quality. Air suspension offers a significantly smoother ride. The airbags absorb shocks and vibrations more effectively than leaf springs, which is especially beneficial for sensitive cargo. Load adjustability. The air pressure in the bags can be adjusted to accommodate different load weights, allowing for better load distribution. This can improve fuel efficiency and handling. Reduced wear. The softer ride reduces wear and tear on both the vehicle and the cargo, extending the lifespan of your truck and its components. Disadvantages: higher cost. Air suspension systems are generally more expensive to purchase and install due to their complexity and the need for additional components like compressors and air lines. Maintenance requirements. Air systems require regular maintenance to ensure there are no leaks or malfunctions. An air leak can lead to reduced performance and even unsafe driving conditions. Trucks configured with air suspension often feature leaf springs in the front for stability while utilizing air suspension in the rear to enhance ride quality and handling, particularly under varying load conditions. 4. Mixed configurations. Leaf spring front, air suspension rear. Many modern semi-trucks feature a mixed configuration, using leaf springs on the front axle and air suspension on the rear. Why this configuration? Enhanced stability. The leaf springs in the front provide a solid, stable platform for steering and handling, especially during turns. Improved comfort. Air suspension in the rear allows for a cushioned ride, which can be particularly beneficial for long-haul drivers who encounter various road conditions. Advantages: balanced performance. This combination provides a balance between load-bearing capacity and ride comfort, making it suitable for diverse applications from long-haul trucking to regional delivery. Adaptability. The air suspension can easily adjust to varying loads, enhancing the truck's overall handling characteristics. Disadvantages: complexity and cost. This setup can increase the complexity of the suspension system, requiring more maintenance and potentially leading to higher repair costs over time. 5. Torsion bar suspension. Moving on, let's discuss torsion bar suspension. This system uses a bar that twists under load to provide spring action. How it works. Torsion bars are anchored at one end and provide resistance by twisting as the vehicle moves over bumps and uneven surfaces. Advantages. Compact design. Torsion bar systems are more compact compared to leaf springs, allowing for a lower ride height and more ground clearance. Smooth ride. They provide a smoother ride than traditional leaf springs, which can be advantageous in lighter-duty applications. Disadvantages. Less common in heavy-duty trucks. While torsion bars are effective for lighter applications, they are less prevalent in heavy-duty trucks due to their load limitations. Adjustment needs. Maintaining proper torsion and alignment can be more complex, requiring regular adjustments. 6. Hydraulic suspension. Next, we have hydraulic suspension, a system that uses hydraulic fluid to adjust ride height and provide cushioning. How it works. Hydraulic suspension systems use a series of fluid-filled cylinders to manage load and cushioning. When the truck encounters bumps, the hydraulic fluid shifts to absorb shock. Advantages. Excellent ride quality. Hydraulic systems can offer an extremely smooth ride, effectively absorbing impacts from rough road surfaces. Load adjustment. Similar to air suspension, hydraulic systems can be adjusted for varying loads, providing optimal ride height and comfort. Disadvantages. Complexity. The hydraulic system is complex and can be prone to leaks, which can compromise performance. Cost and maintenance. Like air suspension, hydraulic systems are expensive to install and require regular maintenance to ensure they are functioning correctly. 7. Walking beam suspension. Finally, let's talk about walking beam suspension, which is commonly found in off-road or specialty trucks. How it works. Walking beam systems use pivoting beams to distribute weight across multiple axles. As one axle encounters a bump, the other can flex down, helping to keep the truck stable. Advantages. Great for rough terrain. Walking beam suspension excels in off-road conditions, allowing trucks to maintain traction and stability on uneven surfaces. Load distribution. The system provides excellent load distribution, reducing stress on individual axles and enhancing tire life. Disadvantages. Limited use. While great for off-road applications, this suspension type may not be efficient for on-highway use, where a smoother ride is preferred. Complex design. The complexity of the walking beam system can lead to higher maintenance costs and potential issues with wear and tear. While the idea of putting the truck driver at the center of the vehicle may seem like a novel approach to improving driver visibility and vehicle balance, the reality is that placing the driver in the center of a truck comes with a host of practical challenges and drawbacks. In this video, we'll explore in detail why putting the truck driver at the center is a bad idea, as well as examine some scenarios why this design is not the future. To understand why placing the driver at the center of a truck is problematic, we first need to appreciate the traditional design of trucks. In almost all commercial trucks, the driver's seat is located on the left side, in countries that drive on the right. This configuration has been the standard for decades, primarily because it provides the driver with the best combination of visibility, control, and ease of operation. One of the main reasons for this design is visibility. With the driver seated on one side, they have a clear view of the road ahead and easy access to side windows for checking blind spots. Semi-trucks and large vehicles rely heavily on side mirrors to see around the vehicle, especially because their size creates significant blind spots. The placement of the driver on the side allows for effective use of these mirrors, which are crucial for safe lane changes, turning, and maneuvering in tight spaces. Another important aspect of the traditional truck design is the interaction with the environment. Truck drivers often need to communicate with toll booth operators, ground crew at loading docks, and weigh station personnel. With the driver positioned on the side, reaching out to hand over documents, make payments, or simply communicate verbally becomes straightforward. Additionally, many roadside facilities are designed with the assumption that the driver is seated on the side, making this configuration more practical. So, why would you place the driver in the center? The primary theoretical advantage of placing the driver at the center of the vehicle is enhanced front visibility. In a central position, the driver can have a more symmetrical view of the road ahead, which might seem like it would help in judging distances and avoiding obstacles. This is particularly appealing in scenarios where precise control over the vehicle is necessary, such as in off-road driving or high-performance applications. In the event of a frontal collision, a central driving position can offer additional safety benefits. By positioning the driver in the center of the truck, Tesla helps ensure that the driver is further from the point of impact, which can potentially reduce the risk of injury. The central driver position allows for a more flexible and innovative cabin layout. By placing the driver in the center, Tesla can maximize the use of space within the cab. This design creates more room for storage, passenger seating, and advanced technology integration. Despite the theoretical benefits, placing the driver at the center of a truck presents numerous challenges that far outweigh the advantages. Let's break down these issues in detail. Reduced side visibility. While central seating may enhance front visibility, it significantly reduces side visibility, which is crucial for safe operation of a truck. In traditional side seating configurations, drivers can easily glance out of the side windows to check for adjacent vehicles, pedestrians, or obstacles. This ability is essential when navigating through urban areas, making turns, or changing lanes. A central position forces the driver to rely almost entirely on mirrors for side visibility, which can introduce new blind spots and make it harder to gauge the truck's position relative to other vehicles or road boundaries. Challenges with lane positioning. Another significant drawback of central seating is the challenge it presents in lane positioning. In a traditional setup, drivers have learned to judge their vehicle's placement in a lane based on their side-seated position. A driver sitting on the left or right side can more easily align the vehicle with the lane markers and maintain proper lane discipline. In contrast, a centrally positioned driver may struggle to accurately judge the truck's position within a lane, especially on narrow roads or in heavy traffic. This misjudgment can lead to dangerous situations, including accidental drifting or encroaching into adjacent lanes. Ergonomics and ease of access are also major concerns with central seating. Traditional trucks are designed for easy entry and exit, with the driver stepping directly into the cab from the side. In a central configuration, the driver would need to navigate across the interior of the truck to reach the seat, which is not only inconvenient but also time-consuming. This could be particularly problematic in emergency situations where quick exit from the vehicle is necessary. Additionally, the entire dashboard and control layout would need to be redesigned to accommodate a central seat. This introduces complexity in the design and manufacturing process, increases costs, and creates a steeper learning curve for drivers who are used to traditional steps. The controls, switches, and display panels would need to be reconfigured, potentially leading to ergonomic challenges and reduced comfort during long hauls. Limited space for co-drivers. The issue of central driver seating in trucks becomes particularly problematic for companies that use co-drivers, a common practice in long-haul trucking. In traditional truck designs, there is typically a passenger seat next to the driver's seat. This allows for the inclusion of a co-driver who can share driving duties, provide assistance, or take over when the primary driver needs rest. Central driver seats eliminate this option entirely as there's no adjacent seating area available for a second person. Moreover, roadside facilities and infrastructure are designed with the assumption that drivers are seated on the side. Toll booths, for example, are positioned for easy access from the driver's window. A central seat would make these interactions awkward and potentially hazardous, as the driver might need to stretch across the cab or even exit the vehicle to complete simple tasks. In conclusion, while the idea of placing the truck driver at the center may offer certain theoretical benefits, the practical challenges and drawbacks far outweigh these advantages in most trucking applications. The traditional side-seated configuration remains the most effective and efficient design for commercial trucks, offering superior visibility, easier interaction with the environment, better ergonomics, and lower costs. The fewer cases where central seating is implemented are highly specialized, tailored to specific scenarios where the unique benefits of a central seat outweigh the drawbacks. For the vast majority of trucking operations, however, the traditional design is likely to remain the standard for the foreseeable future. As the trucking industry continues to evolve with advancements in automation and safety technology, it's possible that new configurations may emerge. However, any such changes will need to carefully balance the practical needs of drivers and operators with the technical capabilities of the vehicles. Until then, keeping the driver on the side remains the best approach to ensuring safe, efficient, and comfortable truck operation. Ever wondered how those big trucks are crash tested and why it's such a crucial process? We're also going to explore the intriguing differences between European trucks and American trucks to determine which is the safest. We'll explore all of that and more in this video. Imagine an 80,000-pound truck cruising down the road at 60 miles per hour. You don't need much imagination to grasp the immense power of these big trucks. Every year, the U.S. witnesses approximately 500,000 semi-truck accidents, underscoring the imperative need for rigorous crash testing. Unlike passenger cars, these colossal vehicles require specialized tests to ensure they are road safe. While traditional crash impact trials are standard, semi-trucks undergo a series of specific tests to evaluate their safety features comprehensively. So let's take a closer look at how they are crash tested. Crash testing for semi-trucks encompasses various types of tests, including frontal impact test. Simulating a head-on collision, this assesses how effectively the truck's front structure absorbs and dissipates crash energy. Side impact test. Evaluating the truck's ability to protect occupants in a side collision. Rollover test. Assessing the vehicle's stability and effectiveness of its rollover protection features. Rear impact test. Examining how well the truck withstands collisions from the rear. Extensive crash testing involves impact trials, including offset barrier and head-on collision tests. Trucks weighing 120 tons are crashed at speeds of 30 to 50 miles per hour, with researchers evaluating damage to test dummies and the truck's cab. These tests provide crucial data for developing improvements to enhance safety in future crashes. Beyond cab tests, semi-trucks also undergo examinations for under-ride guards to protect passenger vehicles. With over 850 U.S. drivers perishing in rear or side collisions with semi-trucks in 2019, under-ride guards are crucial. The Insurance Institute for Highway Safety conducts tests using metal bumpers on the back and sides of trailers, simulating impacts at 35 miles per hour. Unfortunately, these tests are not mandatory for trailers to meet safety standards in the U.S. The collected data undergoes thorough analysis to assess safety system performance, including airbags, seatbelts, and structural components. Researchers scrutinize factors such as the risk of injury to the driver and passengers, vehicle deformation, and the effectiveness of safety features. Semi-truck crash testing is conducted as part of the vehicle development process and regulatory compliance. New models may undergo testing to meet safety standards before market introduction, and regulatory agencies may conduct random or periodic testing on existing models to ensure ongoing compliance. In addition to physical crash tests, manufacturers utilize computer simulations to predict and analyze crash performance. These simulations aid in refining designs and identifying potential safety improvements before physical testing. Ultimately, crash test results play a pivotal role in continuously enhancing safety standards for semi-trucks, with manufacturers leveraging insights gained to improve vehicle design and safety features. But what is the difference between American and European truck tests? Crash testing procedures and regulations can vary between the United States and Europe, and it's essential to note that safety standards are generally developed independently by each region. Both the US and Europe have their own set of regulations and testing protocols for vehicles, including semi-trucks. In the United States, the National Highway Traffic Safety Administration (NHTSA) sets vehicle safety standards and conducts crash tests. The NHTSA evaluates the crashworthiness of vehicles through frontal and side impact tests, among others. In Europe, vehicle safety standards are established by the European Commission, and crash testing is often performed by organizations such as the European New Car Assessment Program (Euro NCAP). Euro NCAP assesses vehicles through a series of crash tests, including frontal, side, and pedestrian impact tests. However, EU regulations mandate a wider range of dynamic crash tests than US regulations. This includes tests for side impact, rollover, and pedestrian protection. This is reflected in stricter requirements for crumple zones, seatbelt systems, and airbag deployment. US crash testing focuses more heavily on frontal impact resistance, reflecting the higher speeds and longer distances commonly encountered on American highways. US test procedures place a greater emphasis on maintaining the integrity of the truck's structure during a collision. This is seen in stricter requirements for bumper and frame strength. Determining which type of crash testing is safer is a complex issue, as it depends on various factors such as the specific test procedures, vehicle design, and driving conditions involved. American conventional trucks with a long nose may offer superior frontal impact protection compared to their European counterparts. This is due to the longer engine compartment and hood, which act as a crumple zone, absorbing the impact energy and reducing the force transferred to the driver and passengers. In contrast, European cab-over trucks with their engine positioned over the cab may expose the driver to a more direct impact in a frontal collision. However, European trucks generally excel in terms of visibility and advanced safety technologies. These advancements include expansive windshields, wide-angle mirrors, and driver assistance systems like lane departure warning and adaptive cruise control. These features contribute to improved situational awareness and can help prevent accidents. Volvo Trucks and Scania are renowned for their Swedish cab strength test, not mandated by international regulations. Simulating the impact of a rollover crash, this rigorous test aims to determine if the cab can withstand intense pressure. A 15-ton weight is evenly loaded on the roof, followed by a 1.4-ton pendulum barrel swinging into the front A-pillar and another into the rear wall. For success, the damage must not breach the driver's survival space, maintaining the original structure. What about the emerging electric trucks? As more trucks are going electric, like Scania's first electric truck, there are new challenges in making sure they're safe in crashes. Unlike regular cars that can put batteries inside, electric truck cabins can't give up space for passengers or engines. Instead, the batteries are put outside in boxes on the sides, replacing the usual fuel tanks. When testing how safe these electric trucks are in crashes, Scania crashes them head-on into a Volkswagen Golf going 35 miles per hour. They do this to see how well the truck's design can handle the impact and protect the batteries. This way, they make sure the trucks are safe while keeping the unique features of electric power in mind. As more electric trucks come out, companies are figuring out better ways to test them and keep everyone safe. In conclusion, the world of semi-truck crash testing is an intricate web of evaluations, simulations, and real-world scenarios. Every crash test serves as a cornerstone in the relentless pursuit of making our roads safer. Whether it's the rigorous Swedish cab strength test or the meticulous analysis of under-ride guards, each examination is a step toward fortifying these massive vehicles. Thank you for joining us on this exploration of the crucial processes that shapes the safety of those behind the wheel and everyone sharing the roads. If you found this video insightful, don't forget to like, subscribe, and hit the notification bell to stay updated on our future content. We hope this ultimate truck education has left you not only with answers to your burning questions, but also with a newfound appreciation for the diverse, powerful, and purposeful machines that shape the backbone of our transportation systems. Thank you for joining us on this enlightening journey. Keep the curiosity alive, the engines roaring, and the highways rolling. Until next time, safe travels on the open road.